Welcome back to Vic's Projects, everyone. I hope you're well. With the Mercedes SL now out on the road, and the old Jag is now in having a well-deserved rest after pretty much a whole winter of service. It needs a bit of a clean. I probably should have washed it before I brought it back in. Anyway, we're not going to be working on that for now. We're going to have a little bit of a break and turn our attention over to the Isetta bubble car. Now, we've not touched the bubble in a while, so I'm super excited to get back into it, especially for today's episode. So, if you recall back, what have we done? We've got a rolling and stopping chassis. So what next? Well, it's a going chassis, isn't it? So with the body off the frame, I'm going to now try and get the old engine mounted in here so I've got room to work around it and see if I can get it running. Now, I'm trying not to split down this engine and rebuild her because, yeah, that's going to take ages and I just want to get the car done as soon as possible. So, I know she's a bit grubby. Once she's on here, then I can give it a good clean. I've got the brackets, which are all powder coated, apart from one, which I forgot. So I'll have to get that one powder coated at some point. Now I've got some of the old rubbers. The shop that sells these is currently closed at the minute, so I'll have to wait for them to reopen. So it's an owner's club. People need to go on holiday, right? So we'll just make these work. A couple of them are broken, so I'll have to figure out a hacky way to just get that all mounted. So it's time to move all this back out again and use our lift. Now the fun bit, trying to get this cute little engine to splutter into life. Now, I don't know the health of this engine at all. I don't know if there's compression. I don't know where the carb is. I hope it's in a box somewhere. I don't know if the ignition works. I don't know if the starter works. But I do know, however, that it turns, at least is free. So, fingers crossed, we're going to be able to get her running. And I'm going to start with what is probably the most complex thing on the entire Isetta bubble car, which is the dynastart that lives in here. So let's crack into that and we can talk about it on the bench. Obviously, we've fallen at the first hurdle because I need two very specialist tools to actually extract this. So I need an M17 by 1.0, what were you thinking, BMW, bolt to pull this off, and then I need a very long M10, thankfully a standard 1.5 thread pitch bolt to then pull the next piece off. Now, thankfully I'm actually going to my first ever BMW Isetta Owners Club meet next week. So fingers crossed, some very nice people from the club will have those tools and be willing to lend them to me. So fingers crossed we get those. Looking inside here, actually all the internals look quite good. So yeah, let's keep those fingers crossed. So in the end, I decided to buy the two tools from the Owners Club because they're handy to have in the toolbox if I've got to work on this again, and they were super cheap anyway. Both of them together were like £10, £15, something like that. So it made a lot of sense. Right, before we use them though, I'm going to put a little dab of grease on the ends here as they're pushers and pullers, so it'll just help everything all move nicely. After a bit of a fight, I managed to get this thing on the bench. Now, I've got a whole separate video going through this in detail. Click the thing if you want to see that. In this video, we're just going to go for a good old-fashioned montage. Yes, she spins. So now we can get on to the next job on our list, which is to try and get a spark. Now, to see if we can get these points going, we need this one back on because it's got this little cam here, which will articulate that guy. But before we put that on, there's a little lubricating pad just there that keeps this metal surface just with a light lube of oil as it's kind of running up and down on that guy. So just any old oil will do. Whoa, there it is. It's quite a bit. I need to clean up this mess. Hold on. So change of plans. It turns out I don't need to turn the engine in order to articulate this because I've got a finger and I can just do that. So I've installed the rest of our ignition system and we're going to have a little 101 on what does all of this circuitry do. So if that's not for you, you can skip this bit. If you want to know, then here we go. So we have what's called a coil, and it is exactly what it says on the tin. Inside here there is a couple of coils, a couple of inductors. We then have this little guy here called a condenser, and basically all that is a capacitor under the hood. So we've got an inductor, a capacitor, we've got a gap here, and then we've got points here which can create a gap. So what happens? Well, in order to understand that, we need to understand a little bit about how these electronic components work. So simply speaking, an inductor will always want to try and maintain the current that flows through it, and it will vary its voltage in order to achieve that. And a capacitor will always want to try and maintain the voltage across it, and will change its current in order to maintain that. A little bit complex, I know, we'll get there. So when we turn this guy on and put some voltage across the coil, so it will just start drawing a little bit of current, this points here will actually open that circuit and stop that current flowing. So this inductor will then ramp up its voltage rapidly to try and maintain the current that was going through it. That's why, or how we generate that huge big voltage in order then to create a spark. So we have a gap here now, and we also have a gap on the other end of the circuit here. And what we want is the voltage to arc across here and not our points. And that's where our condenser capacitor comes in. So it's been sitting across these points up until now and sitting at 0 volts. So when we open this up, it still wants to sit at 0 volts and will change its current accordingly. So as the coil ramps up its voltage, it's not going to allow that voltage to drop across these points, and it will push all that voltage and force it to drop against our spark plug, which is what causes the spark to cross that gap. Simples. So let's try her out. Put that on there, put some voltage across it, and then let's do it that way so you can see, is that actually making contact? Looks like it. So yes, we are getting a spark. Fantastic. It was pretty simple stuff, so I hope it would do. So that's, we can turn the engine, we can generate a spark. Fingers crossed we got compression. The next trick is try and get some fuel. So for that, we're going to jump back in time, but you've just seen me tackle the dynastart. I, however, have no idea how that goes, because right here, right now, I'm waiting for those special tools so I can pull off the fan case. So I thought I'd use the time to crack into this old carb. I think I've got most of it. I'm not sure how the choke works. I'm pretty sure this is throttle cable. That feels like it's missing a part. But anyway, I'm going to tear this down and just see if I can breathe a little bit of life into it with all the original components. So after stripping our old bin carb down, I'd say it's in about average to poor condition. So most of the bits are all there and they all kind of work. I'm going to need some, obviously, new gaskets and things like that. The float still floats, so that's good news. However, I can't find the sealing ring on the top here, the little screw thread job, and I can't find them online anywhere. These guys kind of work. So yeah, it would take me a fair amount of time and money, I think, to get that working. Now, I have heard of people using, with great success, the PZ22 carburetor. Now, this is a carb from a pit bike, 125cc pit bike, but producing about the same amount of horsepower, so it should flow enough fuel. So I'm going to try this just to see if we can get it going, because I still don't know if this engine even works. There is one minor problem though, and that's it's not compatible. You see the mounting points, so I'm going to have to make a little adapter for that. That shouldn't be too much of a worry. I'll get that drawn up in CAD, 3D printed. We can mess around and then get it printed in the right materials. So yeah, let's give this one a go. I need to find a way to get some fuel into it. I'm going to need to find a way to get the old throttle cable to work. I think that will probably work for now. This one here is the choke. So yeah, let's throw this on the engine and see if we can get it running. Okay, moment of truth. Now I've checked our original spark plug. That's sparking really well. We've got our carb on here. It's not permanent, but it will do. Throttle cable, electricity, there's power in the coil at the minute, and for the minute some makeshift fuel rather than trying to fill the fuel bowl with that. So just a bit of easy start. So let's crack on and see how she goes. Whoa, whoa. Oh man, covered in oil. Oh, okay. Now I've jammed this up. This is actually threaded so the dipstick stays in, because clearly we get compression in the oil sump and it pumps oil up here. So with that done, let's go for round two. Bugger. Think something's fried. Probably the brushes on that starter coil. Damn it! Let's have another go with some new brushes. See if it turns. Oh wow. That's so much better. Cool. Let's try our easy start. Fingers crossed. Here we go. Oh, oh. It's backfiring. Oh, we've got a bit of smoke coming out there as well. I don't think the timing's right. Let's have a little look. So if we're getting backfiring issues, then one of the main culprits of that is timing. However, this engine is really simple, so I don't know, I'm not convinced, but we'll go through, do the idiot check and just make sure all our timing is good. So what can happen if your timing's out is as you are opening this valve on the inlet, you could be firing the spark plug at the same time, and then that pushes all that exhaust effectively back out through the inlet and poof, out through the carb. So we've got a timing mark on this fan. I've gone and marked it up with some red pen. That corresponds to a couple of marks on the fan case. We've also got our cams, which are super easy to see. Now, when I got this engine, these cam plates were off. So I don't know if someone's already been in here playing around. That could be the source of our issue. We've also got another timing mark that's buried in there on the crank itself. On the crank? No, on the flywheel. However, someone's gummed it up. So I don't think we're going to need to look at that anyway. We can probably see everything we need from the front here. So let's get it assembled and we'll walk it through and see where our timing is. So here's our timing mark, and then we've got S, O and T. I have no idea what they stand for, but apparently our timing is around here. T is probably top dead center. Here's our spark plug connected, so let's see what point it fires at. So that's around the S. Yeah, it's probably a touch advanced, but not mega. So we're now on the timing mark at the point that it fires. This cam looks, well, that's loose, so that valve is closed. Now let's back it off and see at which point the valve actually opens on the inlet. So there we go. So that inlet valve is well and truly closed. I mean, that's closed there. That is, yeah, like all the pressure is off there, and we're before our S mark. So, that's interesting. Let's keep going around the cycle. So if that is inlet, then we've got spark around there, and then our exhaust cam is loose at the minute. Can you see that? Hold on, let's move it around. Let's start that again, shall we? We open our inlet. This comes round. That then fires with both valves closed. We keep going round, and then, yeah, the exhaust cam opens. Exhaust and inlet. There's a little bit of crossover there. I think that's supposed to happen. And then we're back to inlet, and I can hear it sucking on there, so that's good. Timing looks all right. Okay, let's just go again and see with the covers off here if that tells us anything. So there. Round we go. Balls. So I've not had the choke on till now. I wouldn't expect it to not fire at least, but choke's on, so let's see if that makes a difference. Been trying in vain now for a bit. I think it's time to look at compression. Right, moment of truth. We got the compression tester on here. However, I think I already know the answer because I actually poured a little bit of oil down on the top of these valves as the engine's a bit old and we haven't been cranking it enough to build proper oil pressure to pump it up to the top. So yeah, a little bit of oil just to help move it all around. And when I test to make sure that I can turn this round, I can actually hear the valve leaking. So this is kind of arbitrary, but here we go. Let's see what sort of compression we get. About 50. So thanks for coming along for the ride on this episode of Vic's Projects. Clearly not where I wanted to leave the episode, but I don't know. What a stupid bloody project.